Hello everyone, this is chapter 4 of the Geothermal Energy book by William E. Glassley, Subsurface Fluid Flow, Hydrology of Geothermal Systems. Now, geothermal energy compared to its peers, whether it's generation from fossil fuels or renewables like itself, is quite underdeveloped and quite under-researched. There are many reasons this is true, but all of these reasons mainly stem from the fact that it is extremely difficult to research and model geothermal energy, just because it is hard to get, it's hard to obtain, it's hard to test or measure. So a lot of money has to go into this process, and therefore that is the main reason why it's not as developed and researched as its other peers. Now, the two main factors involved in geothermal energy generation are temperatures and fluid flows. This chapter is going to explore all the details involving the latter, which is fluid flows. Concepts of permeability, porosity, and everything that surrounds them are the main focus that we're going to go through in this chapter and in this presentation. General model for subsurface fluid flow. An advanced understanding of the geological formations of drilling sites or points of interest are essential for the complex procedure of extracting heat and generating geothermal energy. This is one of the most complex sciences when it comes to application, because we cannot extrapolate any data that already exists. 2 points that can be relatively close, like tens of meters apart, can exhibit extremely different behavior, and therefore it's really hard to get a model and then build whatever, or imagine or extrapolate that data to whatever geological formations surround it. Now, one of the main determining factors of how much fluid flow we can expect from a geological formation are the types of rocks. There are generally 3 main types: igneous, sedimentary, and metamorphic. Igneous rocks are essentially melted rocks that have cooled down over long periods of time, so they would usually be from or around a volcanic site. They would have been already melted or melted due to an eruption and have cooled down over a very, very long period of time, or even pressurized. Sedimentary rocks are the ones that have experienced water deposit and or erosion. That is pretty self-explanatory. And then metamorphic rocks are either igneous or sedimentary rocks that have been exposed to really high temperatures and pressures over extreme long periods of time. And that's why they have the branded appearance, as you can see on the image of the rock on the right. All of the lines you see in the middle is due to that unusually high pressure and temperature that they get exposed to over centuries. Of course, a fundamental concept when it comes to geothermal energy, or specifically subsurface fluid flow, are both porosity and permeability. Specifically matrix porosity, because porosity is a concept that can have more than one layer, and we'll get to explore that further throughout this lecture. So what is porosity? Porosity is a physical feature that expresses